Hey everyone, Chang here and welcome to my channel. Now think of this video as a giant summary page in front of any practice test book or math textbooks in general. However, our focus is going to be on trig functions in relation to SAT review. Now, when I browse through a number of different SAT prep books, the different practice tests provided online or in the books itself, right, I realized that there is actually just 6 different topics that you need to understand in relation to trig functions. Once you understand those, basically you have 95% of those topic questions covered. Now, here's the thing. Today's video, for the sake of time, I'm not going to go into specific detail on where you can derive all of them, all the different ways of using the trig functions and all that giant stuff, which is really fun, but probably not practical in relation to just trying to score well in the SAT. Now, each and every one of these topics, I'm just going to briefly touch on it. Hopefully it is a review. If it's not, then it is something that you guys need to study in more depth. So the first one, of course, when we're talking about trig function, we have to mention the 6 trig functions. And I'm going to introduce them or reintroduce them for you guys in a bit. So we have our 6 trig functions, right? And then afterwards, we have to make sure we understand angles. The difference between radian, degrees, how to convert between them, you got to understand that. And the next one we have to understand is, of course, the graphs in relation to the trig functions. You encounter problems that either ask you to graph or at least identify a graph or be able to pull information from the graph as an answer, right? So you have to understand how to graph these 6 trig functions. And of course, then you have your special triangles. Okay, special angles or special triangles, right? Those are the common one that you are usually required to remember, and they're really good with helping you recreate the unit circle and understanding specific angles, right? So we have that, and of course we have our identities. I'm going to introduce some what I feel like are the key identities that one needs to remember or at least derive different identities from. Those are the ones that we need to be familiar with, right? And lastly, of course, you have to understand what inverse function is in relation to the trig function. So these are the 6 topics. If you guys can understand these 6 topics and have them basically in your pocket, you are good to go. So let's just start going through each and every one of them and briefly summarize what you can expect in relation to each of these topics. Alright, so let's talk about the 6 trig functions. Hopefully you guys are somewhat familiar with it. The key thing to remember is this acronym right here. TOA. Okay, and I'm going to explain that in a bit, right? So the reason for that is basically we have our 6, it's going to be sine, cosine, tangent. Then we also have another 3, which is actually in relation to this 6, is cosecant, secant, and then cotangent. Okay, so first and foremost, SOHCAHTOA. The reason you want to memorize SOHCAHTOA is because that's in relation to basically a right triangle. Okay, now wherever your angle is, that's your reference angle. And then SO, ka, and TOA, right? This right here stands for opposite, right? O in opposite, H is hypotenuse, A is adjacent. Now, the reason you want this is because it tells you basically the ratio in relation to your trig function, right? So, sorry, terrible handwriting right there. Hypotenuse and then opposite and then adjacent right here. Okay, so opposite, hypotenuse. Remember that it is a ratio, so the first one's going to be on top, opposite, and the second one, hypotenuse, is going to be on the bottom for sine, right? That's what the S stands for. Ka is cosine, right? That's going to be adjacent over hypotenuse. And tangent, TOA, is opposite over adjacent. Over adjacent. There you go. Right? And so if you are talking about this in relation to an angle, basically, guess what? This side right here is directly opposite of the reference angle. That is your opposite. So whatever this length is, this length right here, the longest length, is known as your hypotenuse, and the length that is actually touching the angle itself, that's not the hypotenuse, that is your adjacent. So hopefully you guys remember that. All right, cool. So sine, cosine, tangent. What about these guys? Well, first and foremost, these guys are basically related to our sine, cosine, and tangent. So they're not something that is completely new that we have to memorize, right? This one right here, the reason I'm writing it like this is because guess what? Cosecant is technically 1 over sine. Okay, secant is technically 1 over cosine, and luckily for us, cotangent, you can guess, is 1 over tangent. Now, a way to remember this is basically remember the opposite. If this is S, the relation must be C. If this is C, the relation must be S. That will help you memorize at least the relation between the two. Sine, that starts with an S. So the 1 over sine is technically cosecant because that's going to start with a C. And this one right here, cosine, right, starts with a C. So the one related to it, that's 1 over cosine, is technically secant, starting with an S. And tangent, cotangent, hopefully you guys don't mix that up too much, right? One of them has a T, or both of them has a T, and well, cotangent and tangent, they use the same word. So there it is. That's 1 over tangent. And then of course, if you really want to go into more details, right, that means you're just flipping these over. So this is going to be hypotenuse over opposite. This is hypotenuse over adjacent, and this is adjacent over opposite. Okay, so there is your 6 trig function and how they are interrelated with each other. All right, so let's talk about angles. Now, angles, there are 2 types of angles. You have your degree, and then you have your radian. Okay, you could tell a degree because they usually have a little circle right next to a number. So if we say 30 degree, they usually have that little thing right there. If it's a radian, it doesn't have that. Okay, now what's the difference? Well, degree, hopefully you guys are familiar. It goes all the way into 360, which is a full circle, and you have 180 is a half circle, so on and so forth. That's the one we're comfortable with. Understand that radian is basically a reference angle. So what do I mean by that? Well, here is our circle, here is our center, here is a radius. A radian is basically the arc length such that whatever your radius is, the length of the arc is the same length. So this is 1 radian, and then you move on, it's 2 radian and 3 radian, so on and so forth. Okay, so that's a different way of measuring angle. That is it, right? One of them is degree that we're familiar with. One of them is radian that we might not be. But the understanding is that whatever the radius is, you're using that length and you're basically bending it around the arc of the circle. And that measurement itself is basically our angle, right? We're saying that this is 1 radian, whatever this angle here is, causes that. And then of course, as you open more and more, then more and more radian. So the key is to be able to convert between degrees and radian. Now, my hint for you, or my trick, is always to remember that when you have your radian, right, just think of it as always in relation to pi. And when you have your degree, whatever that number is, right, think of it as always in relation to 180. Okay, pi is related to 180. If you want 2 pi equals 360, that is fine as well. And from then on, this right here, you just always have to cross multiply, because if they're asking you to convert between radian and degree, they're usually going to give you 3. Right? You know these 2 and 1 more. They either give you the degree and you want to convert it to radian, or if they give you the radian and you want to convert it to degrees. And all you have to do is simply cross multiply it, solve for it, and then you will have whatever degree or radian you need for angles. So when we're talking about graph, there are 2 types of graph. There is what I call a rotational graph. Rotational. And one that I would say regular graph, for lack of a better way to describe it. Now, what do I mean by that? When we're talking about graph, you will see instance where they draw something like this, and here is an angle. I call this rotational graph because basically you're just going to go around the origin right here as your angle increases and decreases, right? Normally you would see this in relation to either talking just about angle or some sort of triangle. Special triangle, right triangle. All right, so that's rotational. That one's very limited. Normally they're talking about degrees. Every now and then they might talk about radian, but I've seen it so few in relation to rotational. It's normally just degrees, right? When we're talking about radian, right? So let's just differentiate this really quickly. This is normally degrees. When we're talking about radian, all of a sudden you see these lovely ones where they break it down into numbers, and then you see sort of like a wave pattern. Now, in order to quickly graph these, just always understand that you're always going to be going up to 2 pi and negative 2 pi. Then you start breaking it into halves. So you have your pi, you have your negative pi right here, and then you're going to break it into quarters as well. Let me just make it so it's obvious right here. Right here, this is going to be pi over 2. This is 3 pi over 2. And this one's going to be negative pi over 2, negative 3 pi over 2. Okay, always break it down to that. And then afterwards, then you have to figure out, are you working with cosine? Are you working with sine? Are you working with tangent? Now, an interesting thing, I've never thought of this before, but then a student actually showed me this. In order to memorize, if you really want to memorize, understand that sine, the word sine has sort of like an S in front of it. Cosine has a C in front of it. So if you really want to memorize it, oh, one more thing. This goes up to 1 and negative 1. So for sine, think of it as you are formulating an S. Starting in the middle, you're going to go up here, right? And then down, then like that. So like an S. Hopefully you guys can see this. Boom. Okay, starting in the center. So let's just go here as well. And then here, here, here. Okay, cool. So that is their way of sort of memorizing it. You can sort of see that it's forming an S just right through the center, tilted S, right? Whereas if you're talking about cosine, so let's just draw it on a different scale, or a different graph so you guys can see it and it's not all jumbled up. Right, there's 4 of them, and then you guys can sort of label them, you know, with the 2 pi and the negative 2 pi, and so on and so forth. I'm not going to go into too much details about that, right? And cosine is a C, so it should be symmetrical. So think of it as flipping a C over, and of course you have your 1 and you have your negative 1. So they start off right here, and then you start going down, down, and then I'm going to ruin my marker just by putting it a lot right there, and then we continue on like that. Okay, so then afterwards you sort of see, if you connect it, there it is, right? That's cosine. Sine, cosine. And cosine right here is symmetrical. You can think of this right here as a sort of tilted C, and here right here sort of a tilted S. So that's just for you guys if you want to use it as a way of memorizing without having to try to figure out which graph belongs to which. But understand that they're still wave. They're always going to be going up and down from 1 to negative 1, and they're always going to repeat after every 2 pi. So notice here is a repeat, here's a repeat, right? Even though this is sort of skewed, right? In 2 pi and always negative 2 pi, that thing is still exactly the same, going up and then going down as like a wave. So that is sine and cosine. Now tangent is slightly different though. Here is another graph, and then we're going to do the whole 4 marks just to represent the different breakdown of the 2 pi's. And then you have your 1, and then you have your negative 1. Now the idea is that, remember, tangent is equal to opposite over adjacent. Okay, so whenever adjacent is 0, then all of a sudden things don't work. Well, the other thing you got to remember about tangent is that's technically just sine over cosine. So whenever cosine is 0, that's when it doesn't work. So let's just look at this graph, for example. When is cosine 0, right? Cosine is 0 at negative 3 pi over 2, right? Negative pi over 2, or pi over 2 and and 3 pi over 2. So basically, cosine is 0 right here, right here, right here. Am I drawing right? 1, 2, 3, 4. Yeah. No, sorry, not this one. That's why it looked weird. Right here, and then right here. Okay, those are going to be your asymptote, because guess what? When cosine is 0, that's when it shoots up like crazy. And then from then on, wherever the middle is, right there and right there. And then of course it keeps going on if you really wanted to. And then you just draw little S's that sort of goes up on one side, goes down on the other. Okay. and then this will go up, and this one will go down, this one will go up, and then there's a go down there. All right, so there is your tangent. Now, I'm rambling a little bit. Now, what about the other three, right? You have your cosecant, you have your secant, and you have your cotangent. Well, guess what? Remember that they are 1 over whatsoever. So cosecant is 1 over sine. So a way to go about it is that when you see this, right? Since it's 1 over sine, once again, we're going to have our little asymptote on wherever sine hits 0. There it is. Okay, now it's just getting messy. But the idea is that if you wanted to draw cosecant, wherever sine is, just understand you're making a U and touching at the exact same point where originally the sine would have touched on 1 and -1. And right there. Okay, so guess what? For cosine or secant in relation to cosine, same thing. You're going to draw the asymptote, and I'm not going to go into details right here. You draw the asymptote, and once again, you're going to touch the U to where it touched the 1 and -1. Now, cotangent is going to be slightly different, but not too bad. It's just going to be a shift of this guy. Notice where tangent is 0. Well, guess what? Cotangent is 1 over tangent, so that's where you're going to draw the asymptote, and then you're going to draw the same S, but the opposite direction. So there it is. That's how you should learn how to graph trig functions. It's probably not going to ask you to do the exact graph, but it will present you with a graph, and you need to be able to identify which is which, or if they're asking you to pull specific information from the graph, you need to be able to do that as well. Alright, so special angles. Now, there's an argument that there's 3, but I want to say there's technically 2 because one and the other is technically related, just a rotation of the other. So the reason for that is because guess what? They say there's a 30-degree right triangle, there's a 45-degree right triangle, and there's a 60-degree right triangle. But if you have a 60-degree right triangle, guess what? That's just the same as a 30-degree right triangle. So if we say here, this is 60 degrees. Guess what? This right here has to be 30 degrees. So 60 degrees, 30 degrees, same thing. So there's 2. I want to say there's 2 triangles that you have to know. And it's not drawn to scale in any way. One of them is the 30, 60, 90. The other one is the 45, 45, 90. Now, the reason for that is because the ratio is what's important. Understand that 45, 45, since they are the same, the ratio is going to be 1, 1, square root 2. Okay, now for the 30, 60, 90, that's slightly more challenging, but remember this ratio. You have a 1, 2, square root 3. Okay, so square root 3 is going to be bigger than 1. 1 is the smallest of the 3, so understand that 1, wherever the angle is the smallest, that's where it's going to be located. So if this is the 30 degrees is the smallest angle, then across from that length, it should be the smallest. So 1 is going to be right here. 60 right here is larger, so that's going to be square root 3 right here. And the largest number is always the hypotenuse. So it's going to be 2 right here. Okay, and if you're ever not sure, always verify with the Pythagorean theorem, a squared plus b squared equals c squared, where a and b is one of the 2 sides that's not the hypotenuse, and c is the hypotenuse itself. Okay, so that's to verify. Now, why is this important? Other than the fact that you will have questions just on special triangles, this helps you create the unit circle. Okay, because when you're doing the unit circle, they're always going to ask you basically special angles. So guess what? If you create the unit circle and then you have a 30 degree, the key to understand that there's a reason it's called a unit circle, because the radius itself is 1. Well, how does that help? It does, right? Because guess what? Once again, this is a ratio. If this is the hypotenuse, if you think of drawing the 30-degree triangle, instead of having this one 60, here's your 30-degree triangle. 60 is now here, right? The number is still going to be the same. 1 is going to be right here. Square root 2 is going to be right here. And then there's, square root 3. And this is going to be 2 right here. Okay? So, if we're trying to figure out basically, right, the ratio, this guy right here and this at the bottom, well, this helps to a degree because this one is 2. Well, if you shrink everything, the angle is still going to be the same. So guess what? If we want this to be 1 in comparison to the unit circle, divide everything by 2. This becomes 1. This is 1/2. This is square root 3 over 2. So in this case, then we know this is 1/2, and this is square root 3 over 2. So understand that these help you recreate the unit circle, and then of course, on situations where they want the unit circle in radian, then you know how to convert this angle into, or this degree into radian, right? Simple as that. So that's the whole point of special angles or special triangles. All right, so common identities, right? There are 4 that you really have to memorize. And if you can get those memorized, a lot of the other identities can be derived from those 4. Now, the first one, luckily for us, is one that we have very little difficulty, hopefully, memorizing because we use it so much. Sine squared x plus cosine squared x equals 1. Hopefully this looks familiar. Now, the reason for that is because just from this alone, you can have 2 more identity that is not as common but may show up. The first one is if you divide everything by sine squared x, guess what? Dividing that by sine squared x, you get 1 plus, and you divide this by sine squared x, cosine x over sine x is cotangent. So all of a sudden you have cotangent squared x equals 1 over sine squared x is basically cosecant squared x. So that's one of the identity. The other one is if you divide everything by cosine squared x, you all of a sudden have tangent squared x plus 1 equals secant squared x, right? There it is. Just from this alone, you have 2 more identity that you might find useful during the exam. The second one, this more complicated one, if you can memorize this one, I think is for the better, but it actually produces a result that is probably one you want more. So what do I mean by that? So first and foremost, sine of a plus b. So you're adding 2 different angles inside sine. That's going to be sine a cosine b plus sine b cosine a, where a and b are the different angles. Now, why is this important? Well, the more common one that you would normally see is if you make a and b the same angle. Let's just say we call it x, right? So all of a sudden you have sine of 2x equals, well, these guys are all x, so you end up having 2 sine x cosine x, right? This is the double angle, right? That's the more common or the more useful of it. Of course, you have your cosine variation, cosine of a plus b. Now, a way to remember this is that if you're talking about cosine, it's always going to start off with cosine first. Cosine a cosine b minus sine a sine b. Okay, so if that's the case, if they're the same angle, that means that cosine of 2x is equal to cosine squared x minus sine squared x. Okay, so that's another one, right? So 1, 2, 3, and then the last one is pretty simple. It's just to convert sine to cosine and cosine to sine. So sine of x is actually the same as cosine of pi over 2 minus x, and the same thing, cosine of x is the same as sine of pi over 2 minus x. And just like that, right? Understand that to memorize this is fairly simple. Just understand it's the opposite. It's always going to be pi over 2 minus x inside when you're trying to switch it. So there you are, the 4 identity that can spawn, I guess you could say small identity that is helpful and useful in the exam. Alright, so we're almost there, right? We're just talking about inverse function. Now the whole thing of inverse function is more of pointing out potential common mistake or misunderstanding instead of actually introducing something completely new. Now understand that for your 6 trigonometric function, your sine, cosine, tangent doesn't matter, right? There's always going to be sine, and I'm going to put a theta here because guess what? This is your angle. And what you have here is some number which is usually your ratio, right? And that's talking about in terms of a right triangle. So that's your normal trig functions. Now, when you're talking about inverse trig, right? So it's going to be sine -1. So be very careful, right? Sine of -1 is not 1 over sine like you would normally think with exponents. That's not the case. Remember that 1 over sine is actually cosecant, not sine to the negative 1. Now, the key about inverse is that it does the opposite. Here in the normal function, you put an angle to give you a ratio, so you can guess. In an inverse, right, what you do is you put the ratio number and it gives you the angle. Whether in degree or radian is your choice. Now, that's the other thing. Be very careful. Make sure your calculator is set to the correct angles, right? There's a degree and radian function. If you start trying to get a radian and it's set to degree, I can guarantee you the mistake is going to be imminent. And same as vice versa, right? If you want a degree and it's set as radian, if you enter whatever number you're trying to do, either get a regular function or an inverse function, it's not going to go well. So be very careful. Once again, inverse function, the understanding is that the regular function, you're putting the angle, you get a ratio. Inverse function, you do the opposite. You put the ratio, you get an angle. There it is. All right, so there you have it. Those are 6 topics that I feel like if you focus and get a firm grasp on it, you'll conquer about 95% of the problems that you would see, if not more, that's in relation to trig functions. Now, here's the thing. Remember, this is a very brief summary. I strongly recommend that you truly study these 6 trig functions and truly understand it in all its glory, because guess what? After the SAT, there's still going to be advanced math that's always going to be using these functions. But hopefully, with this summary, you have everything you need to go kick ass. Thank you for watching this video. If you haven't already, please like, comment, and subscribe. I will see you in the next video.